The next point that we are going to discuss is equilibrium of an object under the action of one force, or you can call it as single force. Let us consider one object, one block over here, and on this block let us assume that one force is acting, that is P. Now under the action of this force P, this object cannot be in equilibrium because as there is only one force, so this force will try to move the object towards the right side, and so object may move in the right direction with some motion, but object cannot be in equilibrium because there is no force present which can balance the P force, and equilibrium that's why equilibrium is not possible. Equilibrium is not possible when only one force is acting on any object. So for equilibrium, minimum two forces are necessary. With only one force, equilibrium cannot be obtained. So let us move towards the next point now, that is equilibrium of an object under the action of two forces. Consider the two diagrams shown over here. Two objects are shown over here, and on both the objects there are two forces acting. So let us consider this first object on which force P is acting in or towards the left side, and force Q is also acting towards the right side, and also one condition is given that P is equal to Q. Now if here P and Q are equal forces, the magnitude of P and Q is same and direction is exactly opposite, then P minus Q becomes 0. That is, resultant becomes 0, and so body is in equilibrium. Body is in equilibrium. Let us consider one more example of same nature. We are having one object in which force P is acting towards left, while one more force is acting at another point, that is Q. But now Q is not horizontal. Instead of that, Q is making an angle theta with horizontal. So in this case also P is equal to Q. It is given that P is equal to Q. But in this case, if you take summation of forces in horizontal direction, it will be minus P plus Q cos of theta. And because of this, you can see that to balance force P, Q cos theta is acting in opposite direction. But as it is given here that P is equal to Q, therefore Q cos theta, this term will be definitely less than Q. And if Q cos theta is less than Q, that means the object will move towards the left side because P is more than Q cos theta. As that means the object will move towards the left side. Now that is because as P is greater than Q cos theta, so equilibrium not maintained. equilibrium is not maintained. So here we can say that to have equilibrium with only two forces, both forces must be equal in magnitude and opposite in direction. Now let us discuss the equilibrium of object or the body under the action of three forces, minimum three forces. So let us consider one object. Let this is one object on which there are three forces acting. And one more force in the downward direction. Let these three forces P, Q and R, these are the three forces P, Q, R. These three forces, let these forces P, Q, R are concurrent forces and keeps body in equilibrium. Here we are assuming that the angle between force P and Q is alpha. Angle between R and Q is alpha. Angle between P and Q is gamma, and angle between R and P is beta. So these three angles are assumed, and we are also assuming that force P, Q and R, these three forces are keeping this body in equilibrium condition. So now we can have a relation between P, Q and R which is given by Lami's theorem. The relation between P, Q and R is given by Lami's theorem. So what Lami's theorem states that is, if three coplanar concurrent forces acting on the body keeps it in equilibrium, then each force is proportional to sine of angle between remaining two forces. So this is Lami's theorem. So mathematically we can write here P divided by sine of angle between remaining two. So if we consider P force, angle between remaining two, that is R and Q, is alpha. So P upon sine alpha is equal to Q upon, now if we consider Q, angle between remaining two forces, that is P and R, is beta. So sine beta equals to R upon, again, angle between remaining two. If we consider force R, remaining two forces are P and Q, so angle is gamma. So R upon sine gamma, and this equation is called as Lami's theorem. But this Lami's theorem is applicable, this is only applicable for three concurrent forces.